Hi friends, welcome back to the channel. Okay, if you are reached episode 10, that itself tells me one thing: you are serious about learning. Okay, not just watching. You are already learned Python basics, right? Okay, we have touched generative AI ideas, but from this episode onwards, we stop writing random code. Okay, and we start engineering intelligence. Okay, today's episode is functions, and trust me, this is not just another Python concept. Okay, functions are the reason robot behave intelligently. Okay, and functions are the reason AI agents feel structured. Okay, functions are the reason large systems don't collapse. Okay, to explain this clearly, I am not going to use boring textbook examples. Okay, like instead of let's imagine Chitti robot, the robot from the Robo movie. Okay, robot does not think randomly. Robot does not act blindly. Every action like scanning, fighting, flying, talking, okay, happens through clearly defined skills. In Python, we call those skills are functions. Okay, in this episode, I will show you how robot skills like Python functions, generative AI prompts, RAG applications, and AI agents, and all these are built using the same core idea. Okay, no shortcuts, no confusion, step by step. So take a deep breath, focus for the next few minutes. Okay, because this episode will change how you see code forever. Okay, let's see. uh, let's deep dive into the functions chapter. Here, I already told robot never performs actions randomly, never has clear defined modes and abilities. Okay, not never, it's clearly defined modes and abilities: combat mode, scan mode, flying mode, self-repair mode. I already told. Okay, functions, a block of code you can run anytime. Okay, function is a packaged piece of work that can be activated whenever needed. Okay, in today's episode we will explore functions deeply. Okay, start from robot behavior and gradually moving into generative AI, RAG systems, and agentic workflow. Okay, step by step, let's see what is function. I already told, like I will explain now. Robotic explanation. A function is like a skill button inside robot brain. When the button is pressed, a predefined action is executed, right? Let's see, like a block of code you can run at any time. Like the function, what is the use of function? Reusability, testability, modular, uh, memory scope, parameterized. I will explain all these functions, no worries. Okay, let's deep dive into our, yeah. Yeah, I have created one function advanced.file. There, let's start with function. How to define function? To define function, or to define a skill to a robot, first of all you have to name it, right? How to name a function? To name a function, simply diff and function name. For suppose, if you want to give a skill to robot, like scanning skill, to scan the area, scan the area. Okay, scan the area. Now let's see here, print Chitti. Chitti is scanning surroundings. Sketch is surrounding area. Okay, you given function. What is the function? The Chitti should scan the surrounding area. This is the function of the, this is the functioning of the function. Okay, functioning of the function, nothing but that is the work that a function to do. If you call the function, so scan mode activated, what will do? Chitti will scan the surroundings. Okay, now how to call it? To execute the function you have to call it. To execute the function you have to call it, right? For suppose Chitti robot you designed, Chitti, scan the area, like that. That is the command. You have to give the command, right? You have to call the command, right? How to call? Simply, you already given the print. Simply, you can scan area command. Simply, that's it. Scan area command. Simple. Simply, see, Chitti is scanning surrounding area. Simply like that, it will give. Okay, that's it. Now here, what is def? What is def? Def I already tell. Simply tells Python we are defining a new skill. We are telling to Python we are defining a new skill. The skill name is scan area. Okay. And what are these parentheses? Parentheses nothing but space for inputs. We can give inputs like move directions, in which direction the robot should move, in what speed, like inputs nothing but parameters. You can define input parameters. Here you can define input parameters like direction, speed and all. Okay, these we can define. I will tell. Okay, here creating a function does nothing by itself. We have to call the function by the name scan area. We already created scan area function. We are calling the function to execute. Okay, indentation error should not be come. Okay, this is how exactly Chitti works. Let's see some why function exists. Here now imagine the robot without functions, all scan logic like fight logic, voice logic, movement logic written in one place. If you written all these in one place, the brain would become chaotic. Functions bring organization. Functions help us like separate abilities, upgrade individual skills, debug easily, build complex systems cleanly. This is why every serious robot or AI systems is built using functions. Now let's see functions with inputs. How to give inputs? We are here how to give inputs or how to give parameters. Okay, let's see. So here why we are giving functions, why we are giving parameters. Robots don't act blindly, right? They receive some commands, right? So how to give the commands? Define function. We have to define the function move. How to move command. How to move in direction, which direction? Any direction. We have to give the direction. Input variable print Chitti is moving. Now we have to call the function. How to call the function I already told. Simply move. We have to give direction. Which direction? Forward direction. Or move command. Simply you can give left. Okay, like that you can simply execute it. What it will give? See, Chitti is scanning surrounding area and Chitti is moving forward, Chitti is moving left. See, same function. Okay, here Chitti is moving forward, Chitti is moving left. Okay, here what we did, direction is external input. The direction is here, this direction is a variable, not variable, it is a parameter, it is an external input. The same function works for this same function works for multiple commands. Okay, multiple commands. This makes the robot behavior dynamic. Okay, let's see some multiple inputs. First, suppose define same function move and direction and multiple inputs. Speed also you are giving. Move Chitti, go forward in 60 km/h. Chitti, go robo, go to left side, left direction with 40 kmph, like that we are giving. Okay, simply but here how to we have to, by while giving two parameters, so define function you have to give colon, and while giving already move is declared, no, let's just comment it, control backslash. Now just simply print. While giving the print you have to format it to give two variables, two parameters, not variables, parameters you can call. Chitti is moving in some left direction, any direction. So sorry, here flower brackets you have to use, you have to declare the, you have to call the variables. If you want to call the variables, sorry, parameters, you have to declare in between flower brackets, and at what speed, speed kmph, km per hour. Okay, that's it. That's it. Now simply you can call move both parameters at a time. Move forward, move forward, comma 60, like that. Simply you can copy it left 40, left 40. Simply you can execute it. See, Chitti is scanning the surrounding area, and Chitti is moving forward at 60 km per hour. Chitti is moving left at 40 km ph. Okay, in this way we can use. Later in upcoming classes, while discussing about LLMs or agents, AI agents, we will call, we when we use AI APIs also, we will call like this APIs. The same, this same idea applies. Okay, like query parameter, model parameter, temperature parameter, top K parameter, all parameters we will implement, right? Yeah, let's see on second. Yeah, here output is like Chitti is moving forward at 60 km per hour and Chitti is moving right at 40 km per hour, right? Here later I already told we will use AI APIs like this only. Okay, let's see return values, how to return values, robot reporting back. So how to when robot, if we ask something, no, we have to get some answer. We will robot, if you give some task to robot, it will give some reply, right? For suppose we need robotic battery levels, battery level, how the battery level is critical or normal. If we want hi Chitti, what is your battery level, is it critical or normal? Now the robot should answer, right, whether it is critical, whether it is normal, how it should answer, right? How it will answer actually based on the level, battery status, battery level only it will. If the battery level is less than 20, it will tell battery is critical, like that. If it is greater than 20, battery is normal, like that it will tell. For that type of return values, to return values, how to write program, we will see. Okay, define function battery level, battery status, for suppose status, battery status, and I am giving level as parameter. Why I am giving parameter? If level less than 20, return less than 20, sorry, it is a condition, right? Battery is critical, battery is critical, we have to give, right? Here colon not required. Rerun turn, sorry, return. Else else return, what should it return? Just battery is normal. If it is not less than 20, then battery is normal, right? Now how to call this? Simply we can call whenever you declare like this, parameter to values, return. Whenever you declare return, right, return, you should almost you must use parameters only. Status variable, sorry, variable, not parameter, it's a variable. In variable we have to put the function battery status. Here battery status, for suppose 15 is there, for suppose battery 15 is there. Now print status, right? Let's run the see, battery is critical, it gave battery is critical, right? Just comment the remaining all, select all and control backslash. Now for suppose battery is 25, what it will do? For battery is 25, what it will do? Battery is normal, like this it will return the values, for particular 20. If you give 20, Chitti's battery is 20, it will return battery is critical automatically. If you write the function battery level status, it will automatically, when battery is 20, above 20 it will show battery is normal, and battery is below 20, automatically it will show battery is critical, robo battery is critical, you need to charge it, like that it will pop up, right? Like that we have to program that function. Here return, what will return do? Sends the result back, okay? Without return, decision cannot be made. Return is the decision making engine, return function is the decision making function, okay? All AI pipelines depend on return values only. In real-time scenarios, while building AI agents or LLMs, all AI pipelines depend on return values only, okay? Let's later see robot decision pipeline. Function calls function, one function calling another function, how to call we will see, okay? Next, let's go. Okay, for suppose just define a function like scan. So now if you want to give a function, what functionality the functionality is to scan the enemies, surrounding by the around the robot, like surroundings, to scan the enemies. If enemy is detected, you have to activate that, activate that attack mode, or else ignore. Okay, now what is the first step? First you have to scan it. So to scan the area, you have to define a function, scan function. In that function you have to put return enemy detected. If enemy detected, it will return. If the scan function returns the enemy detected value automatically based on the result, scan result. If enemy in scan result, return attack. If enemy is there in scan result, you can automatically activate that attack mode, else return ignore. If enemy is not detected, you can ignore. Now based on this, you have to build the program. Like finally you have to act accordingly based on the action. What is the action you have to take? You have to take attack or ignore. Now we have to create attack function to perform the action, act function to perform the action. Okay, like print Chitti action. What is the action? Attack or ignore. Now we have to create again result is equal to scan function. Now first, what are the steps we have to follow? We have to first scan it, later we have to make the decision based on the result, decide result based on the result, and act will takes based on decision. This is the actual functionality, how to take decisions based on the functions, call functions. Let's see. For suppose define function. What is the function? Scan. You are scanning the area. If you scanning the area, if sorry, scanning the area, return enemy detected. Enemy detected. Sorry, return enemy return. Now again, once enemy detected, what will do? Again you have to define one more function. That function, what to do? Decide based on that enemy detected or not, to decide that scan result. If enemy detected, okay, based on the scan result, sorry, not span, based on the scan result, if enemy in scan result, what to do? Return attack. For return semicolon not required, space is enough. Else ignore. Else return ignore. That's it. Now what action you have to take? So to take the action, define act based on that. What to act? Action. Which action you have to take? Ignore or attack? What to do? Print Chitti action. What is the action Chitti taking? Okay. Now in sequential order you have to execute. I will repeat, don't worry. Are result is equal to scan. Result is equal to scan. Later, after scan, what you do? Decision. 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 What is the decision? Decision is equal to decide. You already write decide function. Decide what to decide based on the result. Based on the result, above result. Based on the above result. In above result, scan is scan enemy detected. Based on the enemy detected, if enemy is there, attack. If enemy is not there, automatically it will ignore. Now act. What act? Act already action. Act means decision. 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 Okay, let's print it. Chitti action attack because enemy detected. Enemy is there. For suppose, let's check it whether it will work or not. Chitti action ignore. Okay, Chitti action ignore. There is no enemy detected. No enemy detected. Empty space, empty given. The Chitti action ignored. If enemy is there, anything is there in return. If anything is there, automatically what it will do? It will change into attack mode. See, attack mode. Chitti action attack. Here, like this is a complete robot decision pipeline. Okay, in this way robot will act. We can give functionality. I think no confusions, right? I will explain one more time. Here what we did, simply first we are giving functioning to robots. We are giving some type of work. What is that? Chitti scan. First scan it if enemies are there or not. If enemies are there, return enemy detected. If enemy detected, what to do? To decide if enemy is there or enemy is not there. If enemy is there, what to do? Based on the decide on the scan result. If enemy in scan result, what to do? Return attack. Else ignore. So based on the second one, we are constructed third one. Action. We have to take action. What action? Act. We define one act function. Based on that act function, the Chitti will display like Chitti action. Based on the action, what is the action? Attack or ignore. Now we are calling. We define these functions to do these things. We have to call the functions, right? We are calling first result. Based on the result. Which result? Scan result. If scan result enemy is there, based on the result we have to take decision to decide what to decide the result. Based on the result, now we are calling the here the result is enemy detected, right? Sorry, scan enemy detected. The decision we are giving ignore or attack. Now attack, so attack mode it will be activated. Based on the attack mode it will be activated. And act decision, based on the decision implementation. This is implementation. The third one will implement it, right? Finally the third one will be implemented. That's why we got Chitti action attack mode. Simply single answer we will get. right? Upcoming we will learn some more advanced LLM related, we will get some more clarity. Just be patient and listen, try to understand, try to learn, and be practice. Okay, have some practice. Now generative AI perspective, let's see generative AI perspective. Okay, now pay attention carefully. The exact same pipeline we used for robots uh, here is used in generative AI agents also. Generative AI messages like user system context. Here generative AI related user system context is we need to understand, right? We need to understand. What, how to understand, I will tell. Here for suppose user message is there. User message is nothing but for ChatGPT or Gemini, you are asking some question in text format, right? You as a text format or voice format, you will give whatever it may be. If you give voice mode also, it will convert into text only. User message, it is a text, where now that function, a user message function will get activated. In that function, what they will write now, simply that for that function, simply they wrote role as user and content is text. Okay, user role and content is text. After that, system, for system, what it will do, system message return the role is system, and what to do, content, the content, what is the content, you are an AI assistant, answer clearly and accurately, we have to give it like that. Okay, and also context messages like documents, to read the documents. Okay, to read the rag systems, to read the documents, we have to give content like the context like to join pages. I will write the code, no worries. This is how we control what the LLM sees. Okay, let's see some basic program for user. For suppose diff user message, diff user message is a text variable, text we are giving, and here you have to give what to return, read to you, return what to return, the role you have to return, the role, what is your role, your role is like, your role is here, this is a dictionary we are forming. Okay, role is first user role, what is the user role, and what is the context, like the content, what is the content is in text format, right? Content is in text means that is the text, we are all text is the parameter, right? Sorry, here you have to give comma. Yeah, like this you have to define user message function. To get text from the user, you have to write function like this. For suppose you want to design a ChatGPT or Gemini AI. To get text from user, you have to write function like this. Okay, what is the function to get the text from the user? This is role is user and content is text, like that you have to write. To reply for the text, for the content, to reply for the content, in Python we have to, you have to define again one more function, that is system function, system system message to reply, right? To reply for that, what it will reply, it will reply to the content. What is the return value? Return here role is system role, here the role is system role. What it will do, system automatically replies, the system will replies to the above text, above question, content. Here the content is simple. For first question, while we are using APIs and all, we will get some more clarity. Okay, no worries. You are Chitti AI dot, and we are giving role, we are giving role to system, what to do the system. This is the way of prompting. Okay, one of the way of prompting, we are giving role to system. What the role we are giving based on the based on the content, the context, the rule, the system will answers. Okay, answers with some precise, clear, accurate answers it will give. The content we have, it will give like this: answer clearly and accurately. Like this you have to tell to the system, the answer should give like this. Okay, in this way you have to write. And while coming to rag context, okay, rag context, what to do in rag context? In context message like documents, if while it is reading the documents, how it will read, line by line and page by page, right? Context message, docs from document it is reading. Return, what it will return, same like role it will return, it should return some reply, right? Now it acts as a system role, and that system, what is the content here? Content is what is the content? The context of the message, context of the message. Here line, the slash n is new line, in new line it will give. Okay, and it joins the pages, joins the documents pages, dot join docs and give the reply. It will join all the docs and give the reply accordingly, right? In this way, no worries, in depth you will learn while we are learning rag applications. And in this way I am just to habituate the code, I am telling here itself, but actually while I am telling rag applications agentic AI, at that time I have to tell this role and content and what is what. At that time it will be looks some little bit awkward and critical. That's why I am trying to habituate you this code. Okay, like this we have to write code to LLMs. While we are designing, again we will see, no worries. Okay, actually this is how we control what the LLM sees. Okay, in this way we can simply print that context messages. Okay, let's see some like prompt assembly, like LLM input, how to give LLM inputs. Let's see. First, suppose like to build some prompt like questions, take some parameters like question and docs based from the documents. If we want to question like notebook LLM is there, no, like that on like that LLM, it should scan all the document content and gives reply for that questions from that particular documents, right? This is the complete information packet. Okay, sent to the LLM. uh, let's see how to declare, how to define function. Define, simply we will define build prompt question from the docs. Question from the docs. And return, what to return? Return. Here we are taking list. System system message, list of the functions list we are message functions we are calling. System message
one by one, first system message.
One by one, first system message.
Next, context message. In the context message we have to give docs. Why? We have to read, we have to get the context from the documents. Later we have to frame the user message to question. User message nothing but question. Question we are giving to ChatGPT or Gemini AI, Perplexity, right? That is the question. Yeah, this is the complete information packet sent to the LLM. This is the information. This type of, these are the four: user message, system message, and context message. These three are very important. Finally we have to build the prompt systematically, how the LLM to work. Okay, so first it reads that system message, context message, user message in this way, right? For this context, how the LLM responds we will see. Okay, how an LLM will respond. Okay, here, yeah, the build prompt is there. No, the build prompt, two parameters are there. We are giving two parameters. One is question and docs. Here, what is that? Docs nothing but any PDF you given to summarize or to do something. From that PDF, if you want to ask questions, okay, you can ask. That is the prompt. Now let's see how to just for example, you can print it. Like this, but instead of that we can construct how an LLM can respond. That is called simulation of LLM. Simulation nothing but getting response from the LLM. Simply we can write print statement to print the function. Okay, like this, how many documents, like 5 or 4 pages, like that. But this is not actually practical, just for showing sample purpose, the print statement. Okay, it will give you error. Why? Because we didn't create any response related fake LLM. We didn't create anything. Okay, now yeah, there is no indentation errors, but still we didn't receive any reply. Why? Just we construct the information package sent to LLM. In this way we have to send the information to LLM. Okay, now let's see, we will how an LLM responds, how to construct an LLM to respond, to simulate the LLM. Simulate the means getting response from the LLM. How can we will get to get response from the LLM? Programmer should write some program, right, by using functions and all, right? Here let's see how to write a program to get response from the LLM. Let's see, give me 1 second. Yeah, now just comment it. Let's construct that. First, suppose we are creating one fake LLM, just for fake LLM, just get the response. Okay, in that LLM some messages are there. For that messages it should answer it should answer for that messages it should answer. For suppose print LLM input. Okay, for the message it should display whatever the question we ask. It should display the it should display the answers for the input. Okay, for m in messages, let's see, for m in messages nothing but multiple messages will be there. No, for all the messages it will answer. It will answer. Now print according to the role. What is the role of the system? Like assistant and content. That it acts as a assistant. That LLM acts as an assistant, right? So it should act as an assistant and it should give content like this, the reply. Okay, for the messages what she get, that LLM will get. For that it should reply. Works as an assistant, it should reply. Like for suppose yeah, return what should it return as an assistant? The content it should return. Like for suppose we will ask what is RAG means retrieving relevant data before generating an answer, right? In this way we are constructing a response for the messages, for the questions. Okay, yeah, granting an answer. Let's see in the answer. Now later again we have to call those functions. Like documents we have to call. Just create the documents. Let's see documents. What are the documents are there in that list? RAG stands for retrieval augmented generation, one document, and it improves accuracy using external knowledge. Two strings are there, like two strings, right? It improves accuracy using external knowledge. Like that we will create. Okay, just for sample data. Yeah, using external knowledge. That's it. Like this document, two documents are there. In these two documents we have to query. We will get from in these two we will get answers. Now again the messages. What are the messages? For messages where we can get inputs, we will get inputs from build prompt function. We will get inputs from build prompt functions. For LLM it should get inputs, right? To print the response it should get some inputs. Where it should get inputs? Build prompt. From build prompt function we already defined build prompt function there. Whatever the question we will ask there, that question will go to fake LLM as a message. From that message it takes as input and it responds. The role acts as assistant and the context it will give the answer. That is the motto, right? Reply. What is the reply for that message? First message, what is the reply? The fake LLM. You should call the fake LLM messages, right? Now we have to print LLM reply nothing but LLM reply. Where will we get? From the content, right? From the content in the fake LLM we write, right? The above we write content. Like what we write? RAG stands for RAG means retrieving relevant data and before generating in, like that. Here from the documents itself it will took the response, and it will modify the little bit changes, little bit made some changes, and gives the reply like rag means retrieval relevant data before generating an answer, like that. Okay, yeah, this let just control all and just remove all the yeah, let's remove it. By in this way, this is the yeah, just yeah, it will showing some error. 1 second, why it is showing error, let's see. Yeah, in this way it will give answer. Right, here overall what we did, simply what we did in this program, like you might notice something interesting, right? We are calling a function named build prompt, but at first glance you may not see it nearly near the call. Okay, and your brain immediately asks why, where is build prompt defined? Like, this is very good question, and the question itself means you are thinking like a real programmer. Now listen carefully. In Python, nothing works by magic. Python follows one simple rule. Like, I must already know what a function is before you ask me to execute it. Okay, so whenever you see a function call like this, messages is equal to build prompt, what is rag and docs, the question is, Python immediately looks upward in the file and asks, have you defined a function named build prompt? If the answer is yes, execution continues. If the answer is no, Python stops the programming and throws an error like name error, function not defined. Now let's understand why build prompt exists at all. Like, think like a robot. Robot doesn't directly talk to humans, scan enemies, decide actions all at once. Robot has separate internal skills. Like, one skill defines identity, that is the system message. One skill provides memory, that is the context message, also as rag. One skill receives the human command, that is the user message, right? Instead of manually combining these messages every single time, we create a master function. The master function is build prompt. Okay, its only job is to collect all messages, put them in the correct order, and return a complete information packet that the LLM can understand. Okay, so when you see this line, messages is equal to build prompt, question and docs, like, what is really happening is this, like, robot is assembling its brain's state before speaking, like identity first, memory next, human question last. Okay, once this packet is once this packet is ready, we send it to the LLM. In our case, a fake LLM for learning. Okay, the fake LLM doesn't think, it only prints what it receives, so that we can see how the LLM actually sees our prompt. Okay, this design is not accidental. This is exactly how real AI system works. Okay, like OpenAI, Gemini, Claude, all of them. So if you ever see an error saying function not defined, don't panic. It doesn't mean your idea is wrong. It means one piece of the brain is missing, and once you define it, the entire system comes alive. Okay, here functions are not just code blocks, they are brain modules. Okay, now I think that you understand how prompts are built. Let's go one step deeper and see how agents decide what to do next. Okay, now let's see like that agent decision making, like agent execution in deep detail using our Chitti and generative AI style. Okay. Now we are entering a very important concept. Up to now, we were only sending messages to LLM and getting replies. But real intelligence is not just replying. Real intelligence is deciding what to do next. Okay, this is where the idea of an AI agent is born. Okay, think about a robot again. When when robot hears a command, robot does not immediately act. First, robot asks one internal question: what type of task is this? Right? Is this a search task? Is this a summary task? Or is this just normal conversation? And internal thinking process that internal thinking process is called agent decision making. Okay. Now let's see. One second. In Python, we represent the thinking using a function. Okay, we will see how. Let's see here. We are creating one program. Yeah, in this way it will construct. Okay. One second. Now let's see how to thinking and decision making block we built. Okay, for suppose here take an agent, like agent decision how function. Just create one more function. decide function defined, and in that query, what is the query? For that query, it should reply based on the query. In that query, any summarize is there to summarize that data, any search is there to search from the data, and just like a chart, if it is a chart, like based on the query it will acts. Agent decide function. Okay, this function, from this function only the LLM will decide, the agent will decide to summarize the data or to search from the data, like just we have to chart like that. Here, how to write this block? This is the block. If summarize in query, if there is any summarize in query, return summarize. If else any search word is there in query, it will return search, else it will return chart. Right here, why this? What is this? If any word like summarize the content, summarize the PDF, the word it is there in that, then the question we ask, in the query we ask, automatically it will activate at summarizer mode. Okay, summarizer mode, it will think summarize, okay, we should summarize this, and we have to give the output. We have to search something the query user asked from the data, like that it will, if any search word is there. If nothing is there like summarize or search, simple question you asked, it will like think like some type of charting. Okay, it's nothing but the function is not doing any heavy work. Here it is only thinking and deciding. The input is query, that is the human command, right? Inside the function we check simple conditions. If the word summarize is present, we return the mode summarize, the capital letters. If the word search, small letters, is present, we return the mode search, the capital letters, right? Otherwise we assume this is just normal charting. Here, did you notice something important here? The function does not print anything. It does not execute actions. It only returns a decision. This is exactly how brains work, right? Thinking and acting are two separate steps. Okay? Here, decision making should always be separate from execution. Okay? Here, the robot has decided what to do from this block. The next step is obviously like it should act, it must act according to that, right? That is where the agent execution function comes in. Okay, for that it should give some reply, right? Agent decide, from the above from that agent decide function, it will decides what to do from the query. Now we will again we have to create one more block, that agent execution function block. Okay, agent execution function block. The function, we will build a function called some agent. The function is called agent, and like it acts like a robot itself. It acts like a robot itself. Let's see, build an agent. Define agent query. For that query, it above we take decision, right? This query decision is there. The decision is a variable. We are getting variable value from the agent decision, agent decide function above we declared, right? From that decide function, agent decide function, that answer will hold but here decision variable. Okay, now for that decision variable, if decision is search, it should return searching documents. Some sample reply we are giving. Okay, return searching documents. If the decision is summarize, capital letter summarize, not word, the function, it is a function, summarize function. Okay, if decision is equal to summarize, it is a comparison operator, we are comparing. Okay, return summarizing content, it will return summarizing content, else it will return normal conversation only. Okay, for that we have to write code, return summarizing the content. Later else we will return, first write the summarizing documents. Yeah, 1 second. else. Normal conversation, that's it. Here what happened, from the first line, the decision is equal to agent decide query. This means before I act, let me think. The robot thinks like that. Before I act, let me think. The thinking is like the thinking is delegated to that agent decide function. Okay, that function, that from the decide function it will act. Once the decision is turned, the agent now knows which mode to activate. If the decision is set, we already discussed, robot enters search mode. If the decision is summarized, robot enters summary mode. Otherwise, robot stays in chart mode. Each mode could later connect to real tools like databases, vector search, APIs, or LLMs. Right now we are only simulating behavior, but the architecture is exactly the same as real AI engines. Okay, this is just, we are only simulating behavior, we are just creating some simulating behavior. Actually the architecture is exactly the same as real AI agents. Okay, simply we can call the function print agent search track, like that we can call it later. Okay, now let's see. Here, even like advanced AI agents start with simple if else logic only, like this. Okay, let's see. uh, Finally you can print the output of that simply by using print statement. Yeah, okay, no worries, just simply give the print statement at the end. You can get the result like print parenthesis agent parenthesis some set rag, like that. Give that query, it will get output. Now let's see. Okay, that's it actually. Here what is the big realization is like, whether it is a robot or a chatbot or a rack system or any AI agent, the internal brain structure is the same. Okay, only the output changes. Like for suppose motors for robots, here text for AI. Okay, I am giving some practice tasks. Okay, create robot scan and act functions, build user message and context message. Okay, third one, simulate an LLM response. Okay, fourth one, write agent decision logic. Fifth one, convert robot pipeline into an AI pipeline. Complete these tasks. Okay, today we didn't just learn Python functions, we learn how intelligence is engineered. Okay, in that next episode the robot gains memory and identity using classes and objects. Yeah, that is where true AI agents are born. Okay, next, in next session we will see ops ops concept, right? Object oriented programming concept, like robot gets memory. Okay, until then, thank you so much, bye.